Hello guys, let's finish off with one example from case 4. Case 4 is similar to the previous case where you have quadratic, where the denominator is a quadratic and is irreducible, okay, but now it is repeated, alright, it's raised to the power 2, it could be 3 or 4, alright. So in that case, how do you decompose it into partial fractions? Okay? So given this, you would write this to be equal to the irreducible factor here is quadratic. So you have x squared plus 2. So up here you need a linear factor because this is quadratic. So once again we'll have ax plus b. It is repeated. So again, we are going to have a linear factor with different constants, of course, all over the whole of this. X squared plus 2 raised to the power 2. Okay, so if it is quadratic irreducible, you do it. The procedure is very similar to linear factors which are repeated, right? But now you have irreducible factors that are repeated, so you have linear over quadratic squared. If it is raised to the power 3, it will do the same thing. Ex plus f, if you like, whole over to the power 3. Okay, good. So now you have to solve for a, b, c, and d. How do you do that, right? Same procedure, multiply through by the denominator, all right? So if I do that here, cancel out, we have 2x squared plus 1 is equal to, multiply all of this by this. This factor will cancel out one of this, so you are left with this, right? So you have this thing, ax plus b. This will multiply by one of these factors. Remember, it's squared. So I have x squared plus 2. Okay? And then you multiply this, all of this by this. That cancels out, right? So you are just left with cx plus d. Okay? Good. So from here you can choose one of two methods. You could expand and compare coefficients or plug in values. So let's do the other way. Let's expand it and just compare the coefficients. You can try the same thing technique by choosing values for x. In this case, you'll be choosing 4 values because you have a, b, c, and d. Okay, so that's why I'm going this route. All right, so let's expand this. If we expand it, we're going to have ax times x squared will give us ax cubed. Okay, this and this will give us 2ax. This and this will give us bx squared, right? This and this gives us 2b. And we just have cx, and we clean this, cx plus d. Okay? Then you group the terms. So I still have the highest term. Let me just leave that here. To the power 3. I'll bring the square term. So I have bx squared. The x terms, I'll bring them together. I have 2a plus c. This is x. And then the constant terms, I have 2b plus d, right? So I have the cube, the square, the x term, and the constant term. And then, so 2x squared plus 1 is equal to all of that. Good. So from here, compare coefficients. There is no cubic term here, so a is equal to 0, right? So a, let me do it. So for the cubic terms, from there we can say that a is equal to 0. There is a square term here, right? So b must be equal to 2 if you compare them. So for the square terms, you see that b must be equal to 2. And then there is no x term here, right? Which means that 2a plus c, right, must be equal to 0. So for the x terms, 2a plus c C is equal to 0. But A is already 0, which implies that C is equal to 0. So we have this, guy, we have this already, right? So the constant, for the constant term, 2B plus D must be equal to the constant term, which is 1. We have B, which is 2. So this is 4 here. So 4 plus D is equal to 1, implies that D is equal to 1 minus 4, negative 3. So we have D. Right? Okay. So we solve for A, B, C, and D. We plug them in there, and that should give you your partial fraction. Okay, so let me get rid of this. So this fraction will be equal to, I'm just going to do this. A is 0. All right, let's do this. X squared plus 1, x squared plus 2, all squared will be, A is 0, B is 2, so it's 2 over x squared plus 2. C is 0, D is what? D is negative 3, so I have minus 3 all over x squared plus 2, all of this squared. So that is how you can decompose this, which is the denominator is a product of irreducible quadratic factors repeated, right? So you have this. Okay, so try. Suppose this was a different. I'm going to give you an assignment now. So suppose this was this. How will you do it? Okay. So work through this one. You have 2x squared plus 1, same x squared plus 2, all squared multiplied by x minus 1. Okay, so that's an assignment for you. So try it. So these are the 4 main cases. The fifth one we have looked at it. It's a mixture of different cases, right? Okay. So that will be it for polynomials and rational functions. The next topic we'll look at will be logarithms and exponentials. Okay.